This is example 8. It says find the 6 trigonometric ratios of angle A using part A will be triangle ABC, and part B of this problem will be to use triangle ADE. And so here's the triangles that we're looking at. We have triangle ABC, and we also have triangle ADE. And so these are similar triangles because they share angle A is equal for both. They both have a 90-degree angle, therefore the third angle must also be equal. And so these are similar triangles. And so in geometry, we know that similar triangles have proportional sides, meaning that if the small triangle were to double in size, the side that was 3 will double to 6, and the side that was 4 will also double to 8. Okay, so that's something that we know from geometry. And so before we can find these 6 trigonometric ratios, we need to find the hypotenuses of each of these triangles first. And so line segment AB, the length of that side from A to B, will be the square root of 3 squared plus 4 squared. Right, so that's saying that the hypotenuse will be equal to the square root of one of the sides squared plus the other side squared. And so we did this exact same problem already in the previous example. This is going to be equal to 5. So the length of this side is 5. Okay, and for the bigger triangle, we're looking for the length of side AD. AD will be equal to the square root of 6 squared plus 8 squared. And so the length of that hypotenuse for the bigger triangle will be the square root of 36 plus 64. 36 plus 64 is 100. And the square root of 100 is 10. Square root of 100 is 10. The length of this side is 10. That's the hypotenuse of the bigger triangle. And so we're going to find the 6 trigonometric ratios first using the smaller triangle. The sine of A, which is the opposite over the hypotenuse, is going to be 4/5. The cosine of A is the adjacent over the hypotenuse, that would be 3/5. And the tangent of A would be the opposite over the adjacent, which is 4/3. The cotangent is the reciprocal of the tangent, so it's 3/4. And the secant is the reciprocal of the cosine, so that's 5/3. And the cosecant of A is the reciprocal of the sine, which is 5/4. Okay, so these are the 6 trigonometric ratios for the smaller triangle. And now we'll do the bigger triangle. The sine of A is going to be the opposite, which is 8, over the hypotenuse, which is 10. The cosine of A for the bigger triangle will be the adjacent over the hypotenuse, so that's 6 over 10. Tangent of A for the bigger triangle will be the opposite over the adjacent, so 8 over 6. Cotangent is the reciprocal of the tangent. The secant is the reciprocal of the cosine. And the cosecant is the reciprocal of the sine. And so for the larger triangle, all of these ratios are fractions that reduce. And so 8 over 10 reduces to 4 over 5. 6 over 10 reduces to 3 over 5. And 8 over 6 reduces to 4 over 3. 6 over 8 reduces to 3 over 4. 10/6 is 5/3. And 10/8 is 5/4. And so this proves that the sine of the angle depends only on the actual angle itself, whatever this angle is measured out in degrees. It does not actually depend on the length of the sides of the triangle, right? Because as long as the angles are equal, the sides can vary in length, but the ratios remain the same, and that's because the angle remained the same. Okay, so again, these 6 trigonometric ratios of an angle depends only on the angle, not the actual length of the sides of the triangle.